So we've got an agenda which has only got 3 topics in it. It's really quite simple in terms of the material we're going to cover. We're going to have a look at the cloud landscape, and we'll just have a brief look at what virtualization has done for the cloud and what deployment types there are. What I really want to do is I want to set the landscape first so that we all know what we're talking about when I use certain phrases. So there are phrases like, private cloud, public cloud, SaaS, IaaS, PaaS, and other ones as well, which I'm sure we'll get to in a second. Then I want to talk about what it is that makes the cloud more risky. And finally, we'll have a look at how the risk can be managed. So that, we can't say that moving to the cloud is a risk-free option. It's not a risk-free option. There are some risks. But how do you manage those risks? Could I ask whoever is doing the time to start it? Because it still says 45, and I'd quite like to keep a track of what's going on. Thanks. I'm sure it'll start in a second. Okay, so let's have a look at the cloud landscape then. If you look at an organization that doesn't use cloud computing today, then what they probably have is some compute, some storage, and some network in an on-premise data center. Sometimes that data center in a small business happens to be the server underneath somebody's desk, but it's an on-premise environment with a load of hardware, software installed on it, and on that they'll run some applications. Then, as we've gone through, probably the past 10 years, we've seen the emergence much more of virtual machines. This is the whole idea that you can have one piece of hardware, one server, and you can put lots of virtual machines on it. And, the real advantage of that is that typically a server in a data center is 30% utilized. Well, if you put 2 virtual machines on it, then you could get 60% utilization. You put 3 on there, you could get 90% utilization. All that resource that's not used can be used. And it certainly makes management much easier because you have less stuff to manage. Imagine in this situation that would be 3 separate servers in a traditional environment. So that's an organization without the cloud, and probably most of the people in this room today are running this. You might not know that's what your data center people are running, but this is probably what you're running, a mixture of virtual machines and hardware and the applications installed on both. Now, if we have a look at an organization that has cloud computing, then we will find still most organizations will have virtual machines with applications installed on them. They'll have applications installed directly on the hardware. But that's the on-premise environment. When we talk about the cloud, we tend to talk about the cloud as being out there somewhere. And the cloud is kind of this thing, this big graphic, which is represented by something on the other end of an internet connection, typically. Not always, but typically. And we're talking there about cloud service providers. And so what you could have is an organization that gives users service from the compute, storage, and network resources of a different organization, a completely separate autonomous organization, for which these guys pay these guys for the usage of these applications which are managed in this infrastructure. Okay? This is where the applications themselves are created by the cloud provider, and the service is simply consumed by the organization. That's different to writing your own applications. So when we get to that, then we're really talking about if this organization wants to write an application and run it in the cloud, then they'll be using a cloud platform as opposed to just a ready-made, ready-packaged cloud application. These cloud applications actually can be customized often, but they are ready packaged. You can't really change the functionality of these applications. These, of course, you can because you write your own applications, and they tend to run in virtual machines. That's a really important thing because running an application at a cloud provider inside a virtual machine gives you a really good level of isolation. The damage that can be done by bad code or evil code or code that gets injected into your application through some badness is typically limited just to that virtual machine. So that's a really key thing when you look at a cloud provider is what is the level of isolation that they can provide you for your applications to stop other applications running and getting access to the code that you run. You could imagine if this cloud platform had your application on this virtual machine and somebody else's application on this virtual machine, that starts to sound a little bit uncomfortable. Okay, So typically that doesn't happen. Most cloud operators do operate with virtual machines, and you'll get a virtual machine, and your application will run on at least one virtual machine, typically. Now, what's been happening recently is companies like Microsoft, VMware, the open source movement with the Zen platform, which is used for this VM sort of thing, have started to talk about actually using the technology, virtual machines and applications, but taking some elements of this, in some cases the entirety of this platform, running in a public environment, and just moving the whole thing lock, stock, and barrel into your own organization. And you sort of think to yourself, why on earth would anybody want to do that? Well, the real reason is you can get economies of scale running an internal cloud that you couldn't get by going to an external operator if you're big enough, typically. The thing about the cloud is that you pay as you go, you pay per use. There's a direct relationship between the value that you get from the application you're running and the price that you pay. If you're not running it, you don't pay for it. So you can see that that's attractive, but when you get to many hundreds of thousands of users, it might be more effective, it might be more cost effective to bring some of that infrastructure into your own data center and use that technology which gives you those efficiencies, but own and operate it yourself. So that's where we get to the thing about owning and operating a thing, an infrastructure, yourself. I wonder how many people in this room would really, I suspect there are a few, probably who are working for the MOD or that place over in Cheltenham, or maybe some very specialized government departments, who could say that their data center security is so incredibly tight that it is better than the data center security of the major cloud operators in the world today. And I suspect that most of you wouldn't be able to say that that is the case. That you do have security, you do have good processes, you do have good procedures. The technology that's used is pretty much the same everywhere around the world. The technology doesn't really change. It's down to the processes, the people, and the procedures that determine really how secure the whole system is, as opposed to just the technology. Okay, so we're talking about really three categories. Cloud applications. That was that in the previous diagram. That was this one at the top here. Cloud applications. So cloud applications typically fall into things like Salesforce.com, Office 365, Google Docs, Dynamics CRM Online. These are prepackaged applications. If you take the company that I work for, sells Office 365, what can you do with that? You can consume Exchange as an email service, but you'll never see a backup screen. You'll never restore an Exchange server. You'll never go to the management screen of an Exchange server. All you'll ever get is the interfaces that allow you to connect things like Outlook to that environment. Salesforce.com, they have quite a number of products now, but a number of products, of which the most famous is really their Salesforce.com CRM product, which allows you to do things like customize the application to give you the features that you want, to do the things that you want, even building blocks to build applications. But it's all limited to the functionality that that application exposes to you. You'll never get underneath that system in the way that you can walk into your own data center and think, ooh, there's a lot of red lights on that server. I think I'm going to switch it off, get it changed, and get it reconfigured. You'll never, ever be able to do that in a cloud application type environment. Then we have cloud platforms. So in the previous diagram, it was the thing that was down here. That's where you want to run your own applications on somebody else's platform. So typical examples of those, Google App Engine, Amazon EC2, that's the Elastic Compute Cloud. A little bit of description is quite often needed here. Amazon has this thing called AWS, Amazon Web Services. That is really an umbrella term for all of the cloud stuff that they do. It's all in this thing called Amazon Web Services. And when you want to run applications, you consume this thing here called EC2, Elastic Compute Cloud. It consists of virtual machines, and you put your applications on them, and you run them. Different ways of doing it, but you run them. And then Microsoft has a platform called Windows Azure. Okay, and then there are private clouds. Private clouds typically will use some form of virtualization technology plus other stuff to make it easy to use. So anybody can install a virtualization technology and get themselves what it is that they need. The thing which makes it really easy is when you just go to the portal somewhere and you say, I need a virtual machine of this specification, click the button, and then a few minutes later, it's all there, prepared and created for you, rather than having to do the knife and fork work yourself, which is typically what bare virtualization gives you. But pretty much private clouds tend to use one of those technologies underneath as the basis for which the applications are run. So it will either be Hyper-V, it'll either be VMware, or it'll be the open source Zen platform. Now, what is it that puts the cloud at more risk than than running your own data center? What I'm really talking about here is you can think of the private cloud, you can think of the cloud that runs in your own data center as really being an on-premise environment because you have complete control over that. Remember what I said, the technology that's used in that environment is pretty much the same technology that's used in a public cloud provider. Really, there's very little difference. I mean, they may have tweaked things, but there's really very little difference in the base technology. So what is it that puts that at risk? Well, as I said, there is this symmetry between the base technologies. So we can't really say that technology is a really big problem. The way that technology is implemented can be a big problem, but technology itself, per se, is not the big problem. What would really appear to be the case is that the risk appears to come from outside of the technology itself. Well, I mean, if you consider it, if you've got a set of technologies, and a set of security technologies, and a set of virtualization technologies, and they're running in your data center, and then you were to take that and move it to a public cloud where they'll charge you an hourly fee or a monthly fee to use those services, can you say that there's really a difference between the two? No, you can't really. But what you can say is, I feel really uncomfortable about the fact that that whole environment, that whole infrastructure is going out, and it's going to somebody else's data center, and they're going to run it for me, and they're going to say, trust me, it'll be safe. Don't worry about it, just keep paying the bills. Well, I wonder if that really is the case. And what you're really talking about here is having confidence that the public cloud provider gives you as good or better a level of security than you can obtain yourself by DIY, by doing it yourself. One of the other things to realize is that cloud is not outsourcing. So, all of these problems have existed in the past. You think about bureau processing, how long ago was that? I'm really showing my age here, aren't I? Or outsourcing. You sort of sat there as a manager of an application estate and say, right, I am going to get rid of this problem, get rid of the financial burden of this problem, get rid of the responsibility of this problem. I'm going to give it to an outsourcer, and I'm going to pay them to run it for me. Well, that immediately gives you that feeling of a loss of control. Suddenly, all of that stuff which was once yours is now somebody else's. I know that sometimes you can outsource, actually is an entire outsourced organization comes into your data center and runs the entire thing for you. And you can, if you want to, in those cases, wander down to the bottom floor and walk into the data center and feel the fans. And you can actually touch a machine and feel it vibrating, and it gives you a nice feeling. It gives you a feeling that something is actually happening, that, that there is stuff there that you're still in control of. But when it's away in somebody else's data center, so with like an outsourcing contract, there is still that loss of control, and you're still relying on them. However, what can you do with an outsourcer? You can negotiate a contract that says, I want you to do things in this way. Okay, now if you're going to say to them, I want you to do things in this way, and this is the procedures and the policies that I want you to implement in your data center on my behalf, they will charge you for that. And they will charge you a lot of money for that, because that is the whole point, is that they're going to make money from this, you're going to get an advantage from it, and there's a win-win situation. But you can negotiate to quite a level of detail because, money always speaks, doesn't it? If you offer somebody enough money, they'll do what you say, apparently. But the cloud, most cloud operators operate a commodity service. Microsoft charges, like, Amazon charge, Google, it's all the same, a number of cents per hour for compute. So you could buy 1 hour of compute if you wanted to. If you needed 1 hour of compute time, you could buy that at its cheapest price for 5 cents. So, it'd be mad to end up with a bill for 5 cents. It would cost more to get the bill than it would to actually pay it. But you can do that. And the reason that you can buy either 5 cents worth of compute, or you can have 80,000 cores doing something for you, like Pixar, the animation company, they, it takes 8 hours to render one frame of Toy Story. So they could, there's 420,000 frames in a movie, so you multiply that by 8, and you work out how long it would be before the film was released for them to just do a run and find out if they like the look of it. Or what they could do is they could have several thousand cores, and they could bring that render time down to a number of hours. And that's what they do. They don't want to buy the entire infrastructure that does that, so they rent it. So they rent several thousand compute hours from a cloud provider to do that rendering for them. So you can see why it is that the cloud operator couldn't possibly negotiate contracts, because they're selling a commodity service. They're saying, this is it, take it or leave it. Do you like it? Yes. Okay, this is the charge. Don't you like it? No. We'd like to do this, 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 and this. I'm sorry, the deal is take it or leave it. Now, there are companies that will stand in front of large cloud operators like Microsoft and Amazon and Google and Salesforce and all these sorts of organizations, and they will provide services on top of what the core cloud provider offers. Now, one of the things you obviously have to be careful of in that kind of environment is the organization that fronts the back end making greater claims about things like, say, security and availability than the back end cloud provider actually gives in the first place? In which case, what they're actually doing is they're saying, what we'll do is we'll provide you with a legal remedy so that if we don't meet these obligations, then this is how much money we pay you because we didn't meet our obligations. And they're hoping that that never happens. So, the really neat thing is where the organization that's fronting a cloud operator has a symmetry of availability and security and all those sorts of things, but they're going to make the whole process of obtaining that much easier and much simpler for you. Okay, but remember that the cloud is a commodity service. You pay a number of cents per hour for your compute. You pay a number of cents per gigabyte for the data that you store. And it's done on a commodity basis. One of the questions that quite often gets asked of cloud providers, can I come in and audit your data center? Nope, you can't do that. That's not part of the deal. The deal is that we'll provide the service. If you like it, you buy it. If you don't, then you don't buy it. But the idea of you coming in to audit our data center, from any cloud provider who's operating a cloud, is operating a commodity service, it would cost a fortune to have audits continuously going on inside a data center. And so those are the sorts of things that you have to consider. So what we can say about the cloud is it tends to be an off-the-peg service rather than a made-to-measure service. Outsourcing is a made-to-measure service. The cloud is an off-the-peg service. Now, I just want to talk briefly about the types of cloud computing. So we've got IaaS, and that's this. We've got an on-premise environment, that's this. This is your on-premise environment. You run everything from the networking, the storage, the servers. This is all hardware. Virtualization stack. You manage and patch and fix the operating system. Java, .NET, all the runtimes in the middle here. The applications and the data. This is the stuff that gives the value, the applications and the data. But you still have to do all this stuff down here. And that's why, typically, the cloud is appealing. Because, in an IaaS environment, infrastructure as a service, the biggest proponent of this being Amazon with their EC2 service, all of this is taken away from you. You don't do that anymore. We'll do that. All you worry about is the operating system right through to the application. You look after all of that, and we'll do all of that for you. You compare that with a platform as a service environment, even more attractive. Well, look, we'll do all of this. We'll do all of that for you. All you look after is that bit at the top. And then you look at the software as a service environment, and that's absolutely everything is done for you. There is a little tiny bit done up here. So if you look at, say, Office 365, for example, you'll be given a screen which will allow you to create a mailbox, create a user, set the size limit of the mailbox for that user. But that's about it. You'll never get to, the stuff down here which allows you to tweak the operating system, to put a security patch on the operating system. You never get that in this environment. You do get that in the IaaS environment. Now, one of the things I just want to point out here is where the security risk tends to be at its most sinister is here, where the operating system talks to the virtualization stack, which talks to the hardware. And the reason for this is you have an operating system. It talks to the virtualization software, which makes it look as though it's talking directly to the hardware. That's what it thinks it's doing. Now, the thing is, the virtualization stack, or the virtualization layer here, could be compromised and could be telling the operating system above it that it's doing everything exactly as it thinks it is, but it's doing evil stuff underneath. You know, this virtualization thing, you could say to it, I want you to write a file. So it talks, the operating system talks to the virtualization talks to the server, which talks to storage. But it could be going back up through here into somebody else's application and maybe getting access to their data or giving your data away. So, you know, this is one of the worries about virtualization, is that because the only reporting that you have, the only opportunity you have to find out what's going on underneath all of this is to talk to the operating system and use its APIs. Well, what if it's being fooled by a compromised virtualization stack? And so wherever you see this interface where the operating system and the virtualization stack are together, that's where there is a risk. I have to admit that I think this is an incredibly small risk, but it's a risk. And the thing that you have to ask yourself is, where is the risk of this sort of highest? Well, over here, the only way that you can get into this system, unless you get into the data center yourself, physically into the data center, start pulling servers out of racks and start installing software yourself, is you come in from the top here, but you never get access to anything, certainly in kernel mode. In the platform as a service environment, similarly, you come into the top, you never get really access to any of this. In the IaaS environment and in the on-premise environment, clearly, you get access to everything. Well, you don't get access to the virtualization itself, but you get access to the operating system, which is what's used to install and configure the virtualization. And so what I would say is that as a general rule, this isn't always the case, but as a general rule, what you could say is that SaaS, software as a service, probably has the lowest risk in terms of those kinds of really evil attacks where you wouldn't even know that you'd been compromised, where you'd have no clue until it was too late. PaaS, medium risk, because you do get, you can get some control of the operating system. The amount of the stack that is exposed to you as a consumer of that service is still there, but it's not as high as, for example, the infrastructure as a service, which would have a higher risk because a whole chunk of the stack is exposed. And this is from Spider-Man, isn't it? With great power comes great responsibility. But that's absolutely true. You know, one of the things you've got to really think about with an IaaS environment is security patching. Whose responsibility is it to do security patching in an IaaS environment? It's your responsibility. Even though the cloud operator is somewhere else, it's your responsibility to do that. So Microsoft doesn't actually operate an IaaS environment at the moment. It's in the process of releasing an IaaS environment. But Microsoft's IaaS environment, what we say to you when you run that is, it's your responsibility to patch the operating system. It's your responsibility to make sure that security fixes are done. It's your responsibility to look after that operating system and maintain it in a good state. It's the same with the Amazon EC2 service. It's the same with any IaaS service. And so what's really happened here is you've taken your internal operations and you've said, right, I'm now operating these on an external cloud operator's data center. It doesn't change what it is that you have to do as far low down into the stack as the operating system. Okay, so let's just have a look at the most common risks. Well, you know, the ones that people worry about are things like data leakage and data loss. Because, you know, if you get a data leakage, what do I mean by data leakage? I mean that you are running a system, and somebody has managed to get into that system, get some data out of it, and let's just say publish it on the internet. So let's just say you're an online retailer, and they've managed to get in, find a whole load of credit card information, get out onto the internet, and publish that. What does that do? Well, it's not so much, you know, the technology problem. It's much more to do with what will the mainstream media make of that, and what will the loss of trust of your customer base be, or your potential customer base be, if you don't deal with that type of a situation. So data leakage, you know, that has a really high business impact. So what I'm trying to get across here is that the security of the system doesn't just rely simply on the cloud operator, their procedures and their technologies. Did you notice right at the top of the stack in each of those diagrams there was data and applications? And where do they come from? Well, in the case of a SaaS operator, Office 365, Dynamics CRM Online, Salesforce, something like that, that comes from the operator themselves. But in all of the cases, in all of those other diagrams, they all come from you. You write the application, you send it to them. You create the data, you send it to them. So if you write bad code, then you're going to have exactly the same problem. If you write bad code and you run it in your own data center, or you write bad code and you run it in the cloud operator's data center, and the code itself is insecure, you're going to have exactly the same problem. So you can't escape from the fact that you still have a responsibility yourself to deal with the security of an application. You just don't have to deal with the security of its infrastructure in many cases. With data loss, this is kind of a security problem. What happens if the cloud operator loses your data? Well, you've got to start to think here about things like, in a SaaS sort of environment, then what you would really want to see is some kind of a service level agreement that would say that you could go back to some previous known point. But in the case of PaaS and IaaS environments, where you've sent the application, then things like, because it's your data and it's your applications, it becomes your responsibility to make sure that that backups are taken, or copies of that data are taken, so that if some data gets lost, you can restore that data. The operator themselves won't do that for you. I mean, they'll do things like make sure that the data the binary code that makes up your virtual machines is backed up, so that if they fail, they can immediately reboot them. They will do that for you, and that will absolutely work. But the data that is part of your application itself, that's your data, and it's your responsibility. So data loss, as long as the cloud operator has the facilities to enable you to copy that data, so for example, to do a database copy from one database to another database, this is the online database where the customer data is available to the application, and this is just a copy of the database which is taken at a point in time so that something goes wrong, you can take this data and push it back. But who does that? Well, you do it, of course, because it's your data, it's your application, and you do it in the way that you feel is a suitable method. But again, you have to remember that the apps and the data are in someone else's data center, and you have no right to physically enter that data center. In fact, most of these operators operate data centers they've got hardly any people in them in the first place. Hundreds of thousands of servers with 12 operators, for example. That's not atypical. I don't know. That's normal. You know what I mean. The other thing you can worry about, of course, is that there's lots of data and lots of applications from many customers in the same data center. And that's why I was talking about isolation of service being a really key feature. And that's why I was also talking about cloud operators that tend to operate, an application is built into a virtual machine, because a virtual machine gives you a really nice layer of isolation. Because that virtual machine, to get into another virtual machine, which might be several hundred feet away in a different rack on a different power supply, in a different virtual LAN, and all those kinds of things, somewhere else in the data center, that would be a difficult problem for an evil customer, an evil person, to try and get round. One of the things that quite often comes up is the US, because all the big operators, Google, Microsoft, Amazon, they're all US companies. And there's this thing called the Patriot Act, which says that the US government can say, well, you're a US company, we want to get access to some of the data that you hold under the Patriot Act, which is anti-terrorist legislation. Well, what happens if you give your data to a US company, let's just say that they're running their data center in Ireland, as many of us do, then what happens? Can the US government invoke the US Patriot Act to get access to your data, even though your data lives in Ireland, which is covered by EU legislation? Well, that's an interesting question. I actually don't know the answer to that, and I don't think very many people do know the answer to it. I think my personal view, and I've talked to a few people around this sort of area, especially in our legal and corporate affairs department, is just a view that, let's imagine you're a cloud operator, and you've got one piece of law saying you've got to obey this, and you've got another piece of law saying you've got to obey this. And whichever one you do, if you stick to the EU law, you've broken the law in your country of origin, and there will be some legal remedy for that. If you stick to this law, you've broken the law in the other country, and there'll probably be some legal remedy for that. I think that what most of these operators will do is they'll do a risk assessment, and they'll say, the worst case is if we break that law, so we'll go with that one. Or the worst case is if we break that law, so we'll go with that one. But the thing is, we've got to have it actually tested. We've got to have an environment where something like this happens. And then the other question to really ask yourself when you sort of worry about these things at night, oh, but the US Patriot Act, the US government could get access to my data. What on earth data have you got in your applications that you're so worried about it like that? Just be realistic about this. If you're operating something which you are that worried about it, then probably the cloud is really not a good place to put the data. If you're really worried that the US government might be able to get access to this data and have a look at it. So the risk assessment that you do, don't get really hung up on these kinds of bits of legislation you can get very emotional about these kind of things, but we need to be less emotional and more logical about the decisions we're making. Okay, so when we look at the evolution of the risk profile, then what we can say is that as long as the cloud operator operates some kind of isolation of service, and I've said that one of the really key ways of doing that is to use virtual machines. So an application lives inside a virtual machine. It makes it very difficult for anybody who wants to attack in the traditional way. One of the things you've got to be aware of, though, of course, is that you might not know if your data's been compromised. You might not know if it's leaked out. What's the thing about the public-private key? Do you remember the story about public-private key encryption? It's a fantastic idea, public-private key encryption. It allows us all to spend, to securely do credit card transactions online. That's one of the real neat things that it's allowed us to do. And it was actually invented in 1971 by a guy who worked at GCHQ called Clifford Cox. But in 1973, 74, something like that, 3 mathematicians who formed a company called RSA, they also invented it. But Clifford Cox and GCHQ had to keep it a secret. And it wasn't until this idea had been published and had been around for some time that they said, oh, actually, we did that 3 years before you did. But nobody knew. Because it's not in the interest of security organizations or organizations that are involved in security information to make that kind of thing known. And in the same way, one of the reasons why you need to continuously monitor what's going on with your systems is because you might not know, if you don't put monitoring in place, you might not know that your data has been compromised. This applies actually to your own data center as well. It's not specific to the cloud. I think phishing is still a risk with cloud operators. It does, I think, well, I've got a slide in a few moments on some high-profile cases. And the high-profile cases, they are losses of data that occurred from public cloud data center operators. But really, the risks had nothing to do with the cloud itself. So phishing is where, I do something like, I set up a website, and I call it www.my, let's call it www.yourbanksname.something.something.something.planky.com. Okay, I can buy that domain name if I want to. But if the URL was that long, how much of the URL do you look at when you actually see it in the URL, in the address bar? You see www.whateveryourbanksname.com. And you probably think it's safe. You don't tend to look at the big long string that's after that and find, oh, actually that is a weird domain name that's actually hosted in Azerbaijan. I wonder what on earth my bank's doing in Azerbaijan. You don't really even think about that. And what they do is they make the site look fantastic. It looks just like the real site. And it comes up and it says, what's your account number? What's your password? What's your PIN? Asks you for all that information. You just type it in there and you're just giving it all away. And then what do? They use that to actually log into your real bank account, empty it, put up an error message to keep you sort of occupied for a little while, but it's too late. The data's gone. Well, if they can do that, they can not only empty your bank account, they can get access to all the private information as well. And so phishing still exists as a problem in the cloud, and it's one thing that you have to worry about. So, for example, one of the things that you can do is to use technologies for enterprise-type applications. You can use technologies which take your on-premise identity and authentication and use that against your corporate data, your corporate applications. I'll talk about that in a few moments. Yeah, in fact, I'll talk about it now. So, for example, let's just say you come into your office in the morning and you go Control-Alt-Delete, username, password, you're logged in. You then typically go off, you have a coffee, you talk to somebody, you come back, sit down, you click an icon on your desktop, and you're running an application. Use that for a little while, you go off, you do something else, you come back, you click another icon, you run an application. What if these applications are ones that have been moved over to the cloud? Well, when you move them into the cloud, they're in somebody else's infrastructure. You know, you've got this huge divide called the internet between you and the applications. So what happens now is you click the icon, and the access goes over to this application which is running in the cloud. The thing that you really want to avoid at this stage is going for the simple option, which is to just put up a username and password dialog box and have the user have to remember another username and another password. Because all that's doing is that's introducing an extra security risk, because if you give them another username and a password to remember, they'll probably write it down. It probably will make it easier for some kind of evil organization to try and get access to your systems and just try passwords which might fit, might work. However, if you were to integrate the identity system that is used on-premise, let's just say it's Active Directory, or it's a Novell directory, or it's a Tivoli directory, something like that, whatever it is that you use, if you were to integrate that through a security channel to what's running in your data center, so that what happens is the user comes in the morning, Control-Alt-Delete, username, password, coffee, chat, come back, click an icon. It's those security credentials that they've already used inside the firewall that are used, securely transported across, and gives them access to the applications which are running in the cloud. So that's a really key thing that you can do. And of course, one of the things you want to look for is cloud operators that provide those kind of infrastructure facilities to enable you to make the link between your on-premise identity and your cloud applications. Okay, in fact, we've already talked about that, haven't we? I went a little bit over the top of the previous slide. One of the things I want to talk about, though, is when a failure occurs. Let's just say that, for example, you have a data leak to the internet. Then it's a good idea to think about all the sort of things that could go wrong before they happen, so that you've got this plan. And this plan says, data leak's been to the internet. So you come in here and you get to a decision point. Was it personal data or was it financial data? If it was personal data, then you can just inform individual customers and contain the problem. Really, really, very few people need to know about that. But if it's financial data and it's made big news, then wouldn't it be a really good idea to have a pre-prepared statement that you could immediately respond to rather than going into panic mode? This is all to do with managing the problem that the public disclosure of some kind of a security leak inside your system, whether it's in the cloud or in the on-premise environment. But when it's in the cloud, of course, it will tend to get a little bit more media attention because the cloud is a new technology and they'll be straight onto it. So, one of the things that you can do is you can download this guide. It's currently version 2.1 from the Cloud Security Alliance, cloudsecurityalliance.org. And this gives you sort of guidance for critical areas that you should focus on when you're considering building cloud applications or building them onto, applications onto cloud infrastructure. Currently version 2.1, version 3 is in sort of review and edit at the moment, but they're good documents to have a look at. In fact, there's a sort of a family of documents that are associated with this one, but this one's actually quite a good read. Now, I think I said I'd talk about high-profile cases, and there have been a few. So you can things, the Sony PlayStation problem, Hotmail security breaches, and that also hit Gmail and Yahoo. The Google attack. Really, were they really cloud problems? Well, not really. No, they weren't. The news came out that so the Sony PlayStation, what's it called? I've forgotten the name of the service now. But the Sony PlayStation service got hacked. All that information was made available, and it happened to be running at a cloud operator's data center. They would have still had that problem if it had been running inside their own data center, because the thing that you've got to worry about is that, like I said earlier, the cloud operator will do things like, in a PaaS environment, for example, they will make sure that the operating system is patched to the latest known security threats, but they won't look after your application. So if you write your application in such a way that it's easy for users to get into the top of it and do evil things with it, then you'll still be exposed to the same risks. So running an application in the cloud doesn't get you out of the responsibility you have to write good applications. When you look at Gmail and Hotmail, these accounts were compromised, and they were actually compromised through phishing attacks. So yeah, Gmail is a massive public cloud service offering. Hotmail is a massive public cloud service offering. You know, and there was something like 30,000 accounts. The details of 30,000 accounts got published on the internet. But they didn't get published by somebody hacking into the cloud operator's data center and finding information that way. They got done by automating the whole phishing process, getting people to type their username and password into a page which looked genuine. We live in a society where, you know, if somebody asks us for our username and password and it's on a web page, we just dutifully type it in. And so, really, although there are high-profile cases, what you could say is that these high-profile cases are really about security in general that happens to have run in a cloud data center. Okay, so when we talk really here about cloud lifecycle management for data, and I think most, as I said at the beginning of this talk, most of the big three, and certainly a lot of the other cloud data center operators, will almost certainly run much more secure and tight processes than you do in your own data centers. And the reason for this is because that's what they do for a business. That's their job. You know, their whole thing is they're selling cloud services, and so they want to make them as good as they possibly can, and actually making them secure is obviously a really big part of that. And so that's a lot of what their focus, not all of their focus, but they have a team that is dedicated to looking after security. There's very little human involvement, there's high levels of physical security, and they will typically have biometric physical access control. So you can't just walk into one of those data centers, you know, James Bond style on the back of a truck or anything like that. This is a picture of, well, while it was, one part of it was in construction, of the Microsoft data center in Dublin, 303,000 square feet. It's the size of 4 football pitches, I think. It's actually even bigger than that now because you can see lots of construction going on. The thing to realize about this is how many people work there. It's hardly any people. There's hardly any humans there. And a lot of people think that the attack sort of comes from humans. If you look at the bigger picture of this, and you look at the car park, there's about 12 cars in the car park. You know, and even at 8 o'clock on a Sunday morning, 303,000 square feet, you know, you're talking about a couple of 100,000 servers, probably 1 million virtual machines, and you've got, you know, 12 cars worth of people there running the whole show. So the amount of human involvement is very low, and that's one of the things that is very difficult to reduce in your own data centers is the number of humans that go in there, because they are obviously the biggest risk to security. Okay, so in terms of security policy then, which is, you know, it's good to think of information security policy as a policy which is divided into three pillars. Security, privacy, and regulatory, because that's kind of different to this, you know, the privacy of information. And then service continuity often gets linked in with security because if the data isn't available for some reason, then it has a big impact. And all of these things feed into this thing that we call our compliance management. And that's how Microsoft runs its data centers, and I know that very similar diagrams to this exist for the other two big cloud data center operators. Just to give you an idea of these kind of things that you can do with your own policies, for example, encryption. Encrypt the data before you send it to the cloud and keep your encryption keys out of the cloud. Because if you put the encryption keys into the cloud and they get compromised, then all the data that's in the cloud is also compromised. I was talking earlier about the categorization of information. High business impact, medium business impact, and low business impact. Low business impact, no problem, put it in the cloud. Medium business impact, do a cost-benefit analysis, a COBA, to see what the benefit would be of getting those cloud advantages. And if it's a high business impact, if that was to be compromised, don't put it in the cloud. Leave it in your own on-premise data center. And, of course, compliance. Now, this is a look at the layers of security that are applied to typical cloud center operators. So, I mean, we've talked a lot about things like perimeter network, the internal network, the host, the application, all of this kind of stuff. When we talked about the IaaS, the PaaS, the SaaS, and the on-premise environment. The thing to really look at is the facility, the physical controls, video surveillance, access control, and biometrics, those kinds of things. Because really, you could say that you do everything from network perimeter to application, you do it yourself anyway in your own data center. What you're really doing is you're saying, do I trust the facility and the physical environment that they're running their operation in? And in terms of standards, you know, when you look at standards, actually what they do is they tend to audit processes rather than technology. So, for example, do SaaS, IaaS, and PaaS platforms enjoy security accreditations of some description? I mean, all the big operators do have them. Data centers do as well. So, for example, ISO/IEC 2001:2005, to give it its full name. A lot of people just call it the ISO 27001 accreditation. That is a certificate of registration for the processes that are implemented to look after security in an environment. You can actually get it for your own data center, you know, and the big operators have them for combinations of the service they offer. So, for example, Office 365 as a service has that, but also for the data centers themselves. We're talking about the physical facility. And then you've got lots of things which are to do with, you know, what the auditing was like. So SAS 70 Type 1 and 2 attestations. What this is really saying is that we've carried out an audit of the processes which we use to get that certificate, and we can say that this is done to a good standard. That's what they're really saying. Then there are other ones which apply much more to US companies, like SOX, for example, but Payment Card Industry Data Security Standard, PCI DSS. So, for example, the Amazon and the Microsoft data centers conform to the PCI DSS standards. FISMA is another US one. Something you're going to see a lot more, coming out a lot more is SSAE 16 audit reports. So these are reports on, you can read an audit report of an audit that was done on somebody's security operations in their data center. You'll see that a lot more coming out in the future. Of course, there's lots of legislation that companies have to abide by. For example, the EU's Data Privacy Directive, 9546 EC. You know, they have to abide by that anyway, and so it's actually covered not by anything very specific to the cloud. In fact, none of this is really specific to the cloud. This is specific to data centers. So I just want to end on a couple of things which are making life easy for those who are going to the cloud. One of them is virtual private networks. So this is the idea that you can take your own internal network, it has, you know, resources in it, and you can create a sort of a tunnel which goes into the resources that you have in the cloud, meaning that this part of the cloud becomes part of your own security domain. So you've got a security domain here. I don't know what it's based on, but it's based on something. Being able to have that as all part of the same thing. So, for example, let me take the Microsoft example, because I know that one well. If this is Active Directory, and you've got policies in there for things like, you know, let's just say password policy or some kind of server policy, then those policies can be automatically implemented in these things that are in somebody else's data center. An administrator here makes a change, and the security policy change is reflected in the cloud operator's data center. So that's a really important one. Pretty much all the operators now are actually multiply replicating data inside a data center. You write the data to the data center, and it typically gets written 3 times to 3 separate places. Typically, it's on, you know, data in one place, another place, and another place. Opposite corners of the data center, different power supplies, different flood zones, all of those kinds of things, so that if you had a power supply failure, the data is always available somewhere else. So that's pretty much there with pretty much every operator today. And then also geo-replication of data. So where you've got, you know, a data center in one country, and you can specify that you want, this data is so important to you that you want to replicate it to another country, somewhere else. So that if that whole entire data center goes down, when anybody thinks of an entire data center going down, they always think of earthquakes. But there's a story recently of a big data center going down, and it was due to a lightning strike. Took the data center, took large numbers of customers in that data center out of operation for 24 hours. So geo-replication could obviously get around to those problems. I think these are just some really interesting technology advances which will help with those kinds of problems as we go into the future. Okay, so I said at the start that what we were going to do is we're going to look at the cloud landscape, look at virtualization, how virtualization has given us both the opportunity to do cloud, but also there's a risk associated with virtualization. That's because, you know, that evil code that I was telling you about. I talked about different deployment types, on-premise, IaaS, SaaS, PaaS, all of those kinds of things, and a different type of risk profile that they all tend to have. I also talked about what made the cloud more risky, you know, the idea of multiple tenants, multiple customers in one data center. What if one of them's evil? I talked about legislation, you know, the idea that you have to conform to legislation, whether or not you want to, you have to do that. And I also talked about having an action plan for failures. So predict what the failures could be, have an action plan, and implement the action plan as soon as the failures occur. And then I talked about how risk could be managed, and that was really around security policy, and I just talked a little bit about that there, and also the standards which could be implemented. I'd like to thank you very much for your time. Thank you.